Welcome to Chapter 7, Video 1. This is Miss Lewison. So, how many humans are on Earth? Well, actually, we don't really know that number. That's a hard estimation to get, but the estimation is that there's over 7 billion people. The estimation was that we turned over to 7 billion in October of 2010. And now we are fastly approaching 8 billion, because if you have 7 billion people reproducing, they reproduce fast. You should also know the human population of the United States, which is at 330 million, or about that. Again, it's hard to estimate because people don't always fill out surveys and tell you how many people live in their houses and that kind of thing. The graph on your screen is the graph of the human population. As you look at this, you can see right here, all along here until basically 1600-ish, we were very low, less than 1 million people, and then we started to skyrocket with the Industrial Revolution. And the problem is we're continuing to skyrocket. We're past 7 billion, we're probably somewhere up in here, and we don't want us to get much further. That would be bad. Okay, so does the human population have a carrying capacity? Well, that's a difficult question. For a long time, the thought was that our carrying capacity would be based on food, that we would run out of food, and therefore we would hit a plateau because of competition for food and stuff, and people would starve to death. Well, that didn't end up panning out, at least not at this point, because we keep coming up with really nice inventions like fertilizers and pesticides and irrigation and tractors and stuff that have allowed us to highly increase our production of food, and therefore food may not be our carrying capacity or a limiting factor. However, water might be. Water is very difficult to find and it's very limited, and we use a lot of it. So water may end up being it, but hopefully due to human behavior, we will decide to kind of plateau our population somewhere between 9 and 10 billion people. But we'll have to just kind of wait and see and hope. The graph on the screen now kind of shows what happened with regards to food. It was always thought that our food production would be very linear. It would increase, but in a straight line. And of course, our human population is exponential. Excuse me. And so we always thought there would be this little food deficit where the population was over what the food could produce, and this would become a limiting factor. But in fact, this is more of what's happening. We keep running into initiatives that jump our food production way up. So our food production kind of stair steps up, and so far has been able to keep up with the human population. Okay, so in this video, we're going to talk about several things that affect human population, such as population change in size, fertility, life expectancy, age structure, and migration. Okay, so starting off with changes in population size. We know about births and immigration adds to our population, deaths and immigration subtract. This is a review from Chapter 6. With human populations, it's a little bit more stable in some ways and stuff, but this should be relatively review. So add your births and immigration, subtract your deaths and emigration, and you know what the population change is, at least, if you know the kind of thing. Okay. Some terminology you do need to know that you may not know is crude birth rate, crude death rate, crude this, that, and the other. Anytime you see the term crude, that means per 1,000 people in your population. So if the crude birth rate is 12, that means there are 12 babies born for every 1,000 individuals in your population each year. So if you have 100,000 people in your population, you have 1,200 births. 12 times 100, 1,200 births total. Crude death rate is the same as the number of people who pass away per 1,000 people in your population per year. If you want to look at the global population growth rate in a percent, it is crude birth rate minus crude death rate divided by 10. The reason it's divided by 10 is it's a simplified equation. In fact, you would do crude birth rate minus crude death rate divided by 1,000, because remember it's per 1,000 people, times 100 to make it a percent. But if you cancel out the zeros from the 100 and the 1,000, you're left with crude birth rate minus crude death rate divided by 10. The national population growth rate of like a country, you have to include immigration and emigration. So it would be crude birth rate plus emigration minus the total of crude death rate and emigration divided by 10 as well. There's a lot of math with population. We're going to practice math. Doubling time. Doubling time is a very important equation. You need to know it, and I guarantee you it will be on your AP exam. Doubling time is the number of years it takes for a population to double. So what you do is you take 70 and divide 70 by the growth rate of the population. This is a very simplified formula. It's a very complex formula, but it kind of simplifies down that this works. It's not 100% correct, but it gives you a nice ballpark figure of how long. So if you have a population that has a growth rate of 2%, then 70 divided by 2 would be 35 years. So your population is going to double every 35 years. So if your population is 10,000, in 35 years it will be 20,000. In another 35 years, it's going to go from 20 to 40,000. In another 35 years, it would go from 40 to 80,000. So it doubles each time. Doesn't keep going up by the same increment. It's going to double from one time to the next. Okay? So be careful there, but that's important to know. And we'll practice that. Moving on to fertility. Fertility has to do with births. Total fertility rate is the number of children a woman will have in her lifetime, or basically the average of what a woman in a country will have. Replacement level fertility is what will replace the rate of births that would replace a couple. So the idea is you have 2 children to replace you and your spouse, and that will maintain our population, and our population won't decrease and it won't increase. Replacement level fertility is actually just a little over 1. In most developed countries, it's about 2.1 babies per woman, which means every 10 women would have 3 kind of thing. It would average out to that. The reason is, unfortunately, not all children make it to adulthood to reproduce themselves. So we have to kind of counteract that. If we do not, our population would actually slowly decrease. So we need to bring total fertility rate down towards replacement level and keep it there. You don't want it to go really below replacement level because that can cause problems as well with regards to jobs and taxes and military and all. And we'll talk about that a little bit later. In fact, the total fertility rate in the United States is 1.87, which means the average woman has less than 1 child. Actually, it's 1.84, sorry. That's too low. We actually should try to increase our birth rate here. The only reason the United States is not decreasing in size is that we have immigration. We have a great deal of immigration. So that is helping us to grow very slowly. The United States is growing, but very, very slowly. Not at a bad rate at all. But if we didn't have immigration, our birth rate's too low. We'd have problems. In a developing country where usually more children are going to unfortunately pass away, you're going to need a higher replacement level fertility. It's going to be higher than 2.1, probably around the 2.4, 2.6 range. So if each woman has 2 or 3 children, that would be pretty stable. But unfortunately, in many of these countries, women are having 5 and 6 children. We'll talk about that a little bit later too. Okay, life expectancy. How long are you expected to live? Each cohort is given basically an idea of how long they are expected to live. Our age range is into the 75, 80 year range now for most people in the United States. Women typically live a little longer than men. That can be for a variety of reasons. Because remember, this is the average of everybody. So if you have men who go into the military and unfortunately potentially die younger, that's going to bring the average age down. Men usually also take more dangerous jobs than women on average. And countries with better health care, of course, are going to have longer life expectancy. life expectancy. If we extend our life expectancy, we're actually adding to the population because we're not being subtracted. So that's another way to actually increase your population, is if your old individuals aren't dying, they're staying in the population, and therefore they're going to add to your population. It's kind of a weird thing, but it's true. Okay, moving on. When we talk about life expectancy, we have to talk about death. Infant mortality rate is the number of deaths of children under the age of 1 per 1,000 live births. Child mortality is the number of deaths in children under the age of 5 per 1,000 live births. Unfortunately, many times your child mortality rate is based on socioeconomic issues. In other words, children who are born poor are more likely to die. Sad but true. Usually because of lack of medicine, lack of medical care, lack of nutritious food, parents not having access to education and stuff that would allow them to know how to better care for their children. It's a sad, but in fact, a fact. Children should not die because they were born into poverty, but they do, even here in the United States. The United States infant mortality or child mortality rate is infant mortality rate is 6.6 infants die for every 1,000 births. That is very high for a developed country. It's kind of sad because it is pretty darn high. And with all of our technology and all of our knowledge, we really should not have infants dying like that. Okay, moving on to the next topic, which is age structure. Age structure or age pyramids, population pyramids, give us a lot of information. They are basically graphs showing the males and females at each little age range. It's usually like 5-year age ranges. So 0 to 5 is at the bottom, then 5 to 10, 10 to 15, and on up. So each of those little bars or steps is an age range. And so you can see on average the approximate number of people in each of those age ranges. Please be very careful as you look at these to look at this scale along the bottom. This is for India, and there's 0 to 70 million individuals, and that's just the males who are from 0 to 5. So, you know, there's about 65 million children that are in that age range, which is why they have 1.2 billion people. So each of these are a lot of people. So be careful of the scale because they'll change the scale on you. These pyramids tell us a lot about a population. If it has a very wide bottom, this is really a wide bottom when this is from 0 to 70. That's a pretty wide bottom. It tells us the population is growing fast. It means that they're having lots of children. It also tells us that probably they are less developed, less technology, less medicine, less nutrition, less, care. Okay, other structures. This is a column. It kind of has straighter sides. This is the United States. Usually if it's a column, more of a column or a tower, that tells us that the population is either growing very, very, very slowly or not at all, which is what we want. We want stable. Stable is good. So that's usually a more developed country, more higher socioeconomic status overall on average, more health care, more nutrition, that kind of thing, population stable. The next one, this is Germany. This is inverted. It has that kind of more of a diamond shape. The bottom's narrower, it actually tapers into the bottom. That tells us the population is shrinking in size. It's going down. Population loss, or a decreasing population size, is a very bad thing. We'll talk about it a little bit later, but you don't have young individuals to replace people as they retire. You don't have people paying taxes to support the economy and the system and Medicare and Social Security and all that kind of stuff. So it's actually a very bad deal. And with the case of Germany, Germany knows this, and Germany's having issues, and so they're really, really pushing immigration. You either have to get your individuals who are able to reproduce more, so you have to entice women to reproduce and have more children than they were planning, or you have to have people immigrate, or you can literally have your entire economy collapse, which is kind of scary. Okay, so again, wide bases also tell us not only is the population growing rapidly, it has probably less medical care than other countries, less technology, and a high infant mortality rate. Because women usually have a lot of babies because they are assuming or thinking that half their babies will die. Okay, so here's some, again, chart, or some of these three we've already looked at the age structures. And here's China. You can see China actually looks like it's tapering in, but it's actually kind of becoming stable. It's a little bit more stable, maybe shrinking a tiny bit, but it's becoming stable. That's a pretty decent kind of straight line here, which is a good thing. This little rows in here where they're shorter, that is probably the one-child policy right there affecting it. In the United States, it's hard to see here, but for a long time there was a big bump. This bump is in it, and that was for the baby boom after World War II. It's kind of moved up because most of them are starting to get to old age and starting to pass away. But you can see how there's more females than males in the United States at the older age because they live longer. Okay. So China's becoming rather stable. They're kind of promoting having less children. It's becoming more developed, so people are moving into urban areas, which means they have less children. So we'll talk more about this as we go through the demographic transition model in the next video. Other factors that determine family size are education. If you are educated, you are more likely to have a profession or a seriously demanding job, and therefore will choose to have less children. Wealth is kind of a double-edged sword. If you're really wealthy, you may actually have more children because you can afford them, and you can also pay for assistants to take care of them. Whereas if you're wealthy because you have a very, very demanding job, you may choose to have less children because of that job. In urban areas, usually families have less children because they cost more money. It's expensive to raise a child in an urban area, whereas in a rural area, children can often work and help with the farm and help around the house and that kind of thing. And so often rural families will have more children because there's a benefit to the family. Excuse me. Also, if you live in a country with high infant mortality, of course you're going to have a higher fertility rate in order to compensate for that. If you are under the assumptions, whether actual or not, that half your children will die, you're going to have 6, hoping that 3 make it. And so that's going to affect your family size. Let's go ahead and wrap this up here, and I will start the next video. So this is going to be the end of video 1. Thank you.